In advance of our study of the fundamental theorems of calculus, let's talk a little bit about other fundamental theorems in mathematics. Are there any? What are they? How many are there? And have you learned them before? Let's go back to elementary school when you probably learned this first one, the fundamental theorem of arithmetic, which states that a composite number can be expressed as a unique product of its primes. This is considered the first fundamental theorem that you would have learned in school. You all probably learned it as I did, as the unique factorization theorem, or in other words, factor trees. So let's review a little bit. Remember, the idea behind prime factorization is we can take any number, let's try 36, and we can break it up into a product of its primes. We begin by just simply coming up with two numbers that multiply to 36. So suppose I did 4 times 9. We then keep going until everything has factored down into a prime number. And perhaps you learned another way to set this up than you're seeing here. So what we would have is that 36 can be expressed in terms of a product of its primes as 2 squared times 3 squared. The fundamental theorem of arithmetic was established by the Greeks, more than likely the Pythagoreans, who of course were led by Pythagoras himself. Fast forward a little bit to your days in algebra, where you would have come across the fundamental theorem of algebra, which states that every algebraic expression of degree n has n complex roots. Now remember, when we talk about the complex number system, we are referring to both real and imaginary numbers, terms that were coined by the French mathematician we all know and love, René Descartes. Then in 1748, the Swiss mathematician Euler is the one who actually named that imaginary quantity of square root of -1 to be I. The fundamental theorem of algebra was first stated formally by Peter Roth in 1608. It wasn't until 1797, however, that the first rigorous proof of this theorem was given. And it was given by Carl Friedrich Gauss, the German mathematician who lived from 1777 to 1855. He put this forth in his doctoral dissertation in 1797 at the nice young age of 20. It was Gauss who referred to this theorem as quote-unquote fundamental, and it was the topic of his doctoral dissertation, which was officially entitled "A New Proof that every rational integral function of one variable can be resolved into real factors of the first or second degree." Quite the mouthful. The Hindus, however, knew something of this theorem as far back as 1100 AD. They knew that cubic polynomials, third-degree polynomials, should have 3 roots, and they knew a little bit about quartic polynomials, fourth-degree polynomials, and suspected that they should have 4 roots. But their understanding was a little bit vague because the notions of negative numbers and imaginary numbers were not yet clearly defined. And that brings us up to our study of the calculus. The fundamental theorems of calculus. There are 2 of them. We refer to them as FTC1 and FTC2. If you've seen some of my other videos and are familiar with the controversy that surrounded the establishment of the calculus, you are familiar, of course, with Gottfried von Leibniz and Sir Isaac Newton. Leibniz published the 2 fundamental theorems of calculus in his works between the years 1684 and 1686. But of course, there are some who claim that Newton was the first to have put these forth to the public in 1686 in his work Principia Mathematica. There are a couple other fundamental theorems that you will come across if you continue to study mathematics in college. One is the fundamental theorem of line integrals, which you will come across in higher levels of calculus, and the fundamental theorem of linear algebra. This also was set forth by Gauss, and this fundamental theorem deals with row space in matrix algebra. There is another set of postulates that many do consider to be fundamental as well. And I know you have heard of all these. They are Euclid's 5 postulates, which create the basis for what we now call Euclidean geometry. These were set forth by Euclid. Remember that Euclid was from Alexandria in Egypt. He lived around 300 BC, and he is considered the father of geometry. He set forth these postulates in his famous work, Elements, which basically includes everything you and I studied in geometry in high school. The 5 postulates states, first, a straight line segment can be drawn joining any 2 points. Number 2, any straight line segment can be extended indefinitely in a straight line. Number 3, given any straight line segment, a circle can be drawn having the segment as a radius and one endpoint of the center. Number 4, all right angles are congruent. And finally, number 5, which we all learned as the parallel postulate, which states that a given line and a point not on that line, there exists exactly one line through the given point parallel to the given line. So this notion of fundamental theorems in mathematics definitely carries through from the young, early ages in elementary school all the way up through higher mathematics. And now we turn back to our study of the calculus and the 2 fundamental theorems of calculus.